Alright, so we're going to get started here with graphing rational functions. For you online learners, we just walked through Mr. Solberg's guide to graphing, and it was wonderful. We all loved it. Now you need to do that, and then we're going to get to this. Okay, step one, we need to figure out the end behavior asymptote. You said that was by comparing what? The degree of the numerator, degree of the denominator. Guys, what's the degree of the numerator? What's the degree of the denominator? How do those compare? 1 is less than 2. What does that tell you about your end behavior asymptote? Y equals 0. So I just have HA, that's for horizontal asymptote. My horizontal asymptote is just y equals 0. So if the degree of your numerator is less than the denominator, you get y equals 0. So I'm going to put a little dashed line at y equals 0, just like that. Okay, that takes us to step 2. We're finding the vertical asymptotes. Now, we were told that the vertical asymptotes is whatever makes the denominator become 0. It's a little harder to tell what would make that become 0 because it's in standard form. What form would be easier to tell? Factored form. Hey, so Angelina, how would you factor this? X squared minus x minus 6. What would you say there? Let's check that. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Sounds good to me. Good job. Now, we don't want x to be whatever makes this become 0. So what values can we not let x be? 3 and negative 2. These are going to show up as your vertical asymptote. So I'm going to put a note here. X cannot be 3, and x can, or well, okay, sorry, let me change that. So for our domain, so I'm going to put a little note over here. Our domain is that x cannot be 3 or negative 2. So what are we going to put at 3 and negative 2? We're going to put a vertical asymptote. So I'm going to say the line x equals 3 is a vertical asymptote. Same with the line x equals negative 2. Remember, y equals is a horizontal line if it's y equals a number. X equals a number is a vertical line. These are vertical asymptotes, so we do x equals. So I'm going to go over to 3 and put in a dashed line like that. And I'm going to go to negative 2 and put in a dashed line like that. Alright, are you with me? You okay? That takes me to step 3. We need to find the x-intercepts. We read in the notes. Where do we get the x-intercepts from? The numerator. I look at what would make the numerator become 0. Well, x plus 1 equals 0. That's pretty simple. What would make that become 0? 1. So I'd say there's an x-intercept at 1. So I'm going to come and put a dot here at 1, because that's my x-intercept. Great, now I go to step 4. This is finding the y-intercept. We're just going to plug in 0, or what I'm going to do is just cover up the x's, because they're just going to turn into 0, okay? So if those go there, what is left over? I've got negative 1 over negative 6, which is what? Positive 1 over 6, right? So that's pretty close to 0. It's right about here. Alright, now that's all the information we have so far. So this is where, well, let me just ask you this. Is that enough information for us to know what this is going to look like? Not really, okay? The more you work with this, the more familiar you'll get and you'll figure out some tricks. But this is where we're going to use a sign array, okay? Now, what's going on this left side? One of two things can happen, okay? We're going to go from one asymptote to the other. And it's either going to be below or it's going to be above. Okay? So we've got one of two choices, below or above. Same with here on the right side, it's going to be below or above. On the inside, our choices here, it's going to go from one to the other. It can either make a U or an S curve. Now, a way that we're going to check that test to figure out what's going on, we're going to make a sine array, which what a sine array is, it's basically a number line, okay? And I'm going to draw under here so I can kind of match it up. So we're saying, when is this graph going to change from positive to negative? Well, it could change at a vertical asymptote or an x-intercept. So I'm going to put a note here at -2 and say, hey, this is one of my vertical asymptotes. That's where the graph could change from positive to negative. At 1, we have an x-intercept. And that's another point, excuse me, that's another point where it could change from positive to negative. Also, we have a vertical asymptote at 3. Now, if I'm wanting to figure out whether it's positive or negative, all I'm going to do is I'm going to plug in a point and figure out if it's positive or negative. So, let's start over here on the right side. What's a number that's bigger than 3? 4 is a great number. I could choose any number bigger than 3. That seems like the easiest one to work with. So what I'm going to do is I'm going to plug in 4 to my equation. And I'm not too worried about what I get as far as like the value of it, but I'm trying to figure out whether it's positive or negative. Because if it's positive, then it tells me it's going to make that shape. If it's negative, it's going to make that shape. Alright? So let's go and let's plug in 4. So I'm going to put a little note here. I'm going to plug in 4. When I do, 4 minus 1, that gives me 3. And then in the bottom, 4 squared is 16 minus 4 minus 6. Okay, so that's going to be 3 over 16 minus 10, which is 6, so that's going to be 1/2. Now, what matters there? It's going to be 1/2, but what's important is that 1/2 is positive. So are we going to be above the x-axis or below? We're going to be above. And I even have a little key point now. Great, so at 4, it's at 1/2. So, show me with your hands, what does 1 over x look like? Ninja stars, show me. What we're going to do is we're going to take one of those ninja stars, but we're going to draw it right here. That's our ninja star, okay? Since it was positive, we know it's going to be above, so it's going to look like that. Mine was a little loopy, curvy there, but whatever, okay? That's the idea. Okay, now let's test a point over on the other side. What's a number that's less than -2? Let's do -3. That would be the easiest one to do, okay? And we're wondering, is that going to give us a positive or a negative value? Okay, so now I'm going to test -3. When I plug in -3, I'm going to get -3 minus 1. That's going to give me -4. And here I'll get -3 squared. That is 9. Bless you. Minus a -3. That's going to be plus 3 minus 6. So that's going to be -4 over 12 minus 6, which is 6. So that's -2/3. So at -3, I'm at -2/3. What does that tell me about all the points that are less than 2? They're all going to be negative, right? Because the only place it can change from positive to negative is at an x-intercept or a vertical asymptote, and there's not any of those over here. So all of these points here are negative, so what will that look like? Kind of do the ninja star again, but now it's going to be like that. So I'm going to graph that in. And those are going to be kind of the two ends here. Now, doesn't that look just like the ninja star that we did at the beginning? There's our ninja star. Now, what's going on the middle? We could have either, what did I say? We could have either a U or an S curve. Now, I've got to go through this y-intercept, and I've got to go through that x-intercept. Do I bounce or do I cross? Let's think about polynomials, what you learned about those x-intercepts. When would you bounce versus when would you cross? So good. So not degree though. What's the word we're using here? How often a root is used? What's the vocab word there, guys? Multiplicity. Good job. For my x-intercept, what was its multiplicity? Was it squared? Was it cubed? No, it's just, it was to the 1 power, right? So it's only used once, so what's going to happen there? It's going to cross. Now, technically what could I do here? Could I plug in a point between negative 2 and 1? I already have. I plugged in 0, and what did we get? We got a positive number, right? We got positive 1/6. So I know I'm positive like this. Now, I could plug in a number between 1 and 3 like 2, okay? And it would tell me that it's going to be negative. But I already know it's going to be negative there because the only way it could go back to positive were if it bounced, right? How do I know it doesn't bounce? The multiplicity was 1, so therefore it's going to cross and come down like that. And there is your graph. Was that a decent amount of work? Yeah. It was your first one, but the more we do this, the better that'll feel. Hey, do me a favor, get out your Chromebooks real quick. Go to Desmos, and I want you to graph this. When you do graph this, you've got to put parentheses around the numerator and denominator. But try to quickly log in, get pulled up to Desmos, or if you have a graphing calculator or whatever, but just check your work on this. Does it look like that? I'll give you about a minute. Is there a Desmos app?
Yeah.
What? Do you guys all have it downloaded? Well, I would encourage you to. That would be awesome. So right now you're checking your work. Is that what this looks like? Alright, I'm seeing about half of your screens have it. You guys feeling good about this? Okay, now, before I move on, let me just go over how we got this, okay? First off, how did we get the horizontal asymptote? We compared the degree of the numerator to the degree of the denominator. Since 1 is less than 2, we knew we'd get y equals 0 as a horizontal asymptote. To get the vertical asymptotes, we looked at the denominator and said, hey, what makes those become 0? Whatever it does is our vertical asymptote, so we had a vertical asymptote at -2 and at 3. To get the x-intercepts, we just took the numerator, set it equal to 0, and solved and got one x-intercept at 1. Then we plugged in 0, got our y-intercept at 1/6. Then to figure out whether it was positive or negative, we just plugged in values. Now, can I show you a little shortcut here? Notice that the vertical asymptotes, if I'm going down on one side, what's going on the other side? It's going up. They go opposite directions. If I'm going down on one side, what's going on the other side? It's going up. So technically, how many points did I need to plug in? Just one. If I knew it was positive here, well then if it's going up, what's going on the other side? It's going down. And then I knew it would cross there because of multiplicity of 1. It's going up, so what's going on this side? It's going down. So you're going to learn some tricks that are going to make it easier as we go along. Now, that's not always the case. If you can actually get multiplicity with your x, or with your vertical asymptotes. But that's more something you'd see in 1050. For now, let's just keep it a little simple. Okay, I want you guys to take a second and see what you can figure out from this one. So on this one, I want you to go through your steps again. Compare your degrees. Factor the denominator. Figure out the vertical asymptote. Figure out the x-intercept, the y-intercept, and try to get those, at least those. And then we'll come together and graph those, all right?